Pluto is a remote and confounding, more unpretentious planet that was once important to our Sun's planetary framework but was subsequently renamed as a dwarf planet. However, astonishing discoveries by distinguished astrophysicists like Neil deGrasse Tyson and Michio Kaku have brought Pluto back into the spotlight. They suggested that this cold world is on a potential crash course with Neptune. But how might this be possible, and what might be the consequences of such a stupendous event? Is this a fascinating cosmic anomaly, or is there something more to it? 34 seconds. This approaching celestial spectacle raises many questions. Join us as we examine the possible outcomes of a Pluto-Neptune impact. Pluto, a former planet that was reclassified as a dwarf planet partly due to its unusual orbit, remains a subject of great interest and study in the astronomical community. Recent examinations by leading experts indicate that Pluto's orbit is dangerously close to Neptune's. Both Tyson and Kaku have raised concerns about a potential catastrophic collision between these two bodies, which could pose a serious threat to Earth. 1 minute and 7 seconds. But how is such an event even possible? Pluto's orbit around the Sun is unlike that of any other planet in our solar system. It takes an astonishing 248 years to complete a single orbit. Since its discovery in 1930, it has not yet completed one full revolution. However, the fascination with Pluto doesn't stop there. Its orbit is notably elongated, deviating significantly from the nearly circular orbits of the major planets. What makes Pluto's orbit even more surprising is its inclination. It is tilted at 17 degrees relative to the ecliptic plane. Pluto's movement is significantly more slanted compared to other planets, adding complexity to its orbital path. One of the most intriguing aspects of Pluto's orbit is its intersection with Neptune's. For about 20 years during each orbit, Pluto actually moves closer to the Sun than Neptune, challenging our traditional understanding of planetary positions within the solar system. 2 minutes and 15 seconds. This raises the natural question: why hasn't Pluto collided with Neptune? The answer lies in the gravitational interactions of various planets. The study of Pluto's orbit began shortly after its discovery. Astronomers initially struggled to understand its peculiar trajectory, especially compared to planets with orbits closer to the ecliptic plane. Pluto's orbit stood out due to its steep inclination and elongated shape. The mystery deepened when it was confirmed that Pluto's orbit crosses Neptune's. The stability of Pluto's orbit, despite these complexities, is a testament to the intricate design of celestial mechanics. The three-body problem in space physics, which determines how three objects, such as Pluto, Neptune, and the Sun, interact gravitationally, is a fundamental concept. It is akin to predicting their future positions based on their initial locations and gravitational influences on each other. 2 minutes and 46 seconds. In Pluto's case, this problem reveals how Neptune's gravity and the Sun's gravitational pull interconnect in a complex manner. Concepts like libration, resonance, and the Kozai mechanism are crucial in understanding this puzzle. Libration in the specific context of Pluto and Neptune suggests that whenever Pluto crosses Neptune's orbit, it is positioned at least 90 degrees away from Neptune. This spatial separation is key in preventing a collision. Resonance refers to the periodic motion of a celestial body within its orbit. For Pluto, this means that when it comes closest to Neptune or another giant planet, it is perfectly aligned above their orbital plane, providing an additional layer of protection. The Kozai mechanism, named after three scientists, von Zeipel, Kozai, and Lidov, studies how gravitational influences affect orbital stability. This oscillation explains why Pluto's orbit remains stable despite its apparent irregularity. 3 minutes and 54 seconds. Although Pluto's path around the Sun may seem unpredictable, its orbit remains consistent over billions of years, suggesting that its movement follows a specific order. Predicting cosmic events, especially involving chaotic orbits like Pluto's, presents significant challenges. The inherent unpredictability of these systems means that long-term forecasts are riddled with uncertainties. While numerical simulations are valuable tools for understanding and predicting the future movements of celestial bodies, they also highlight the limitations of our predictions. 4 minutes and 26 seconds. These models rely heavily on the accuracy of initial conditions, and even the smallest deviation can lead to vastly different outcomes, making precise predictions an arduous task. The intricate nature of celestial orbits, such as Pluto's, reminds us that our understanding of space remains incomplete. The gravitational influences of the giant planets on Pluto's orbit provide valuable insights into the broader dynamics of our solar system. They demonstrate how the position and presence of each planet can significantly impact the stability and behavior of other objects within the system. But why are prominent astrophysicists like Neil deGrasse Tyson and Michio Kaku raising concerns about a potential collision between Pluto and Neptune, despite the many forces preventing such an event? 5 minutes and 28 seconds. Tyson, an influential astrophysicist known for his role in Pluto's reclassification, offers a compelling perspective on the mysteries of our solar system. He views Pluto's renaming as a dwarf planet not as a demotion but as a refinement of our understanding of celestial bodies. Tyson's approach to astrophysics is one of continuous learning, and he sees Pluto's orbit as further evidence of how much we still have to discover about space. His work emphasizes that as we learn more about the universe, new questions emerge, pushing us to explore further and refine our knowledge. 6 minutes and 30 seconds. Michio Kaku, a renowned physicist and futurist, provides a different yet complementary perspective. Kaku is known for his ability to connect complex scientific ideas with visionary concepts. He emphasizes the chaotic forces that shape our universe and advocates for continuous observation and advanced modeling to predict and understand potential cosmic events. Kaku sees the possibility of a Pluto-Neptune collision as a reflection of the dynamic and often turbulent nature of space. He believes that studying the interactions between celestial bodies is not just a matter of academic interest but also has practical implications. He warns that events like a Pluto-Neptune collision could have far-reaching consequences, from reshaping our understanding of the solar system to potentially requiring future space interventions. 7 minutes and 31 seconds. Both Tyson and Kaku stress that space is an arena of limitless discovery. While our current understanding is vast, it remains limited. The prevailing scientific consensus holds that Pluto and Neptune's orbits will remain stable for the foreseeable future due to their mean motion resonance and various gravitational influences. Thus, a direct collision between Pluto and Neptune is considered highly unlikely. However, the complexities and potential disturbances in orbital mechanics mean that astronomers must continue to monitor and study these celestial bodies to better understand their long-term behavior and any potential risks they may pose. 8 minutes and 2 seconds. While a Pluto-Neptune collision remains a largely speculative scenario, it highlights the importance of ongoing study and observation in astronomy. Advances in technology, including improved telescopes and computational models, will help astronomers refine their simulations and predictions. This ensures that we stay ahead of the ever-changing nature of our solar system. Tyson's perspective on Pluto's reclassification, along with Kaku's emphasis on the unpredictable nature of celestial mechanics, both underscore the need for continuous research and a flexible understanding of our universe. The potential impact scenario between Pluto and Neptune serves as a case study for the challenges and opportunities in space exploration, emphasizing the necessity of rigorous scientific inquiry, cutting-edge technology, and a willingness to adapt our understanding as new data emerges. 9 minutes and 38 seconds. Pluto continues to captivate scientists and space enthusiasts alike with its distant and enigmatic nature. While its status as a dwarf planet has long been debated, its orbit and unique characteristics continue to attract researchers. Recent developments have once again placed Pluto in the spotlight, particularly with the possibility of a gravitational interaction between Pluto and Neptune gaining attention in the space community. With Tyson and Kaku bringing this topic to the forefront, discussions surrounding a potential Pluto-Neptune collision are certain to spark further research and inquiry. Studying these complex celestial bodies holds the promise of revealing new insights into the mechanics of our solar system. As we peer deeper into space, the dynamic and unpredictable nature of our cosmic neighborhood underscores the need for vigilance and ongoing exploration.